Imperva, a Thales company, is the cybersecurity leader that helps organizations protect critical applications, APIs, and data anywhere, at scale, and with the highest ROI. With an integrated approach combining edge, application security, and data security, Imperva protects companies through all stages of their digital journey. Imperva Threat Research and their global intelligence community enable Imperva to stay ahead of the threat landscape and seamlessly integrate the latest security, privacy, and compliance expertise into their solutions. Start a free trial today at securityweekly.com/Imperva. Welcome back to Application Security Weekly. We just talked with Stu McClure about AI, agents, RAGs, and rewriting insecure code with LLMs. I'm your host, Mike Shima. I'm here with John Kinsella and Akira Brand. And John, Akira, let's dive right into the news. There's kind of a lot this week, and the kind of is that's a metric measure of the amount of news. I'm not sure how I could further expand on that. So let's dive right into something. One of the things I grabbed was we were talking about polyfill.io and Cloudflare last week, John. And this week I pulled in Cloudflare's application security report. This is from their 2024 update. And the reason, I pulled it in because I do like the Cloudflare blog. So I do have a bias toward just, did they write about something interesting? In this case, they talked about there's shadow APIs out there. Okay, I think we kind of know that. We've talked about that with guests in different ways. But for me, what stood out was the amount of third-party JavaScript that they see their customers, they see these websites loading, that they're talking about on average of 47 scripts and a median, and I appreciate they were showing the median and average numbers here, but a median still of 20 third-party scripts. And just what comes to my mind there is thinking about that polyfill and how deliberately or with intention are web apps owners out there expanding their attack surface. Here's a bunch of third-party JavaScript code, either written that you're loading or being loaded from that third party that you technically don't have much control over, and there's a lot of trust there. So I don't know if that kind of grabs you as well, or if there's much we could unpack there.
Mike, just really quick, I want to talk a bit about what Cloudflare does for for our people that may not understand or know of Cloudflare. So Cloudflare does a lot. It's a really big company. It offers a lot of products and services. The main ones: CDN, DDoS protection, WAFs, DNS services. What's also interesting to me is they offer some performance optimization, which I'm still learning a little bit more about. But functionally, if you have video or images or audio, it helps you actually increase the efficiency of that in your web apps. And I don't know a lot about how it does that in also a security context, but I thought that was kind of interesting that like a seemingly security company does also some performance optimization. But it's just good to know that Cloudflare has so much data. They monitor so much across the web that, sometimes when I look at reports, if I'm not familiar with the source, I want to look into the source to make sure it's actually legitimate. And this is, if you're not sure what Cloudflare is, you can just trust that this is a legitimate source.
Yeah, I think I would also probably frame them more as like a networking or traffic company, for the lack of a forest or quadrant, rather than a security company. Sure. But clearly, they can come sponsor, and you should get a commission, Akira. One of the things I will also say, I run my blog off of their pages. You can actually just use GitHub and have a hook that generates a static blogging platform for them. So I do use them a lot. So full disclosure there. But John, what you've been listening to us go on now. We need to hear your voice in this conversation.
I feel educated. So right after that list you just mentioned of the 47 median third-party scripts, the next section they had was enterprise applications connected to nearly 50 third parties on average. Man, that's the one. I mean, I know we're all talking about like supply chain and that type of thing, and usually we think of that from just pure code and how many libraries your npm pulls in. But when you're actually connecting out to that many other things, that's the sort of the second scary wave to me. That's a lot of people to trust. Is versus you can secure your code during the build, right? And like you've secured it, it's there. You pinned your versions, everything's great. But if you're connecting out to 50 other, I'll call them applications, yeah. They can go bang at any point after you've hardened all your stuff. That's a little scary to me.
Yeah, it doesn't matter if you've done that vendor security checklist on day one, on day 1+N. Who knows what that looks like? So yes, hopefully that's my snide remark against just using checklists and spreadsheets for the modern enterprise age. But let's go beyond that into something that's a little bit more fun. I have an article here about WebAssembly from the CNCF, but that feels like it ties into something a little bit fun that you had, John, about Python Monkey. What the heck is a Python Monkey?
Yeah, let's come back to that. The WebAssembly one. I'm looking for my right tab because there's no way I'm going to remember this. So Python Monkey is, where did it go? There it is. Well, according to them, deep breath, a Mozilla SpiderMonkey JavaScript engine embedded into the Python VM using the Python engine to provide the JS host environment. So really what they're doing is they've created ability to run, if I get it right, JavaScript within a Python client. I'm sure there's a good reason for this. I see mention of CPython, so maybe some performance. I'll be honest, I haven't looked too deeply into this yet. I saw those, when the headline I saw this had a few of those words mentioned, I'm like, okay, I must click. And that just had to be my funny haha before we go back to a little more about what you found in that WASM article.
Yes, and JavaScript, it runs everywhere. Eventually, all these server-side JavaScript uses, I like to say, eventually it'll show up in the client as well. But the WebAssembly, this is an article from the Cloud Native Computing Foundation. They're talking about, I'm framing it as where is WebAssembly. They're saying it's the next wave of cloud native computing. And I like this. To be clear, a lot of WebAssembly appeals to me in the sense that you can compile it into sandbox environments. You can compile it into ways that don't have access to an operating system or file system, I should say, because a lot of times you don't need that. So there goes all of our path traversal attacks, classes of vulnerabilities. There are memory safety things you can do. There's a lot of introspection you can do on the code that feels like it's going to address, again, lots of these vulnerability classes. What makes me worried is that there's some arguments in here of like, well, it took a decade plus for things like Kubernetes to get adopted from the foundational components within the Linux kernel. And I'm like, okay, but that's not the best argument because we also have it's taken a decade of blockchain examples for people to realize that blockchain still isn't solving any problems out there. No emails, please. But this is where I want to see WebAssembly solving more problems, but we don't really come across many projects using it, frameworks using it, or good examples of it. And I guess this is more of my, am I missing those examples? And if so, please, listeners, send some in, or just what's missing that developers aren't embracing this enough?
So first, it would be a tragedy. Along with you, I'm a big fan of getting rid of classes and vulnerabilities, but we can't get rid of directory traversal, Mike. That's just, come on.
That's the day we close the podcast. Yeah.
Yes, that's the end. Seriously, I think WASM, I'm curious your thoughts here in a second, Akira, but I think WASM has sort of found its own little space and it's living there nice and happily. Most recently, I don't think we covered on here, I'm seeing some people talk about using WASM instead of eBPF, both for either the classic network manipulation, which is capable of, or the security rules. Just because by itself it is, it's user space, but also it's sandboxed by default without having to worry about what's going on in your kernel. So I think it's going to be around, I think, but that's just from where I'm sitting. Akira?
I want to know more about the actual components and how they relate to WebAssembly, because we have the WebAssembly tool, but then they also talk about the components in this article. So it's interesting to talk about that there's a additional specification that these components have to adhere to. It's called the component model. But from my understanding, it's kind of like a library. But I was also curious, like Mike or John, if you can maybe shed some more light on that for our listeners of what the component is inside of WebAssembly and maybe what it relates to maybe in another programming language.
Well, to have a little bit of fun, like John did with the Python monkey language, there's the one answer could be that, Akira, this represents, quote, a new inflection point, and the next paradigm shift is already underway. Quoting from the blog. Sorry, have to tease a little bit about the writing here, but. If you wanted to understand what those paradigm shifts are underway, some of that modularity is the idea that, if you look at JavaScript and NPM modules, it's a wild west, to use a lazy metaphor, in the sense of they pull in a lot of modules. Dependencies can be hard to express. Basically, there's been a lot of, call it ground up development of how modules within the NPM world should interrelate, call each other, can they nest, etc. How can they be constrained? What WASM is trying to do is turn that on its head and say, let's start with a couple of standards or some agreements on what format we want modules to be in, so that they can be pulled in, that we can have dependencies. And this comes from a similar world, I'll say, of like Rust. So you can compile Rust code into WASM. Depending on what you're calling, you might not have all the networking stack, things like that, but that's really what they're trying to aim for, is the sense of, we want to be able to have something that is reasonable and composable, in the sense that we know what modules we're pulling in, and these modules have behaviors that are predictable. Hopefully that gives a decent idea. I see John nodding, so I don't know if he wants to, I think that's completely throw something else in there, or what would you want to add? Yeah.
No, I think you summed it up quite nicely, and it lets our listeners know that we actually do dive a little bit deeper than just look at the headlines on some of these.
We try. Yeah, so Kira's, you're very helpful for these questions, because we don't want to always assume, just a shared understanding of the articles we're going into. So I appreciate that. With that, so I'm going to pull in, speaking of shared understandings, let's talk about why quantum is unimportant to quote post-quantum. And here, I'm actually not going to talk about post-quantum cryptography really much, or AES-GCM or AES-GEM, or a couple of things that are just fun different modes. This is a blog from Trail of Bits that, if you scroll towards the end of it, there's a section just titled Modern Design. And this is what stood out to me, is that the author's point is more about that we still have not seen in the public sphere a quantum computer that has actually attacked anything. So it's good for the security community to be moving to different algorithms, to moving away from just a purely factorization-based algorithm, because the promise of quantum computers is that they can trivially, hand-waving a little bit, solve those types of problems. They're no longer hard, 100-year plus types of burning through your CPUs or GPUs to solve them. But the point here at the end that they make is that the implementations that these post-quantum algorithms have been using are just by design constant time implementations, meaning that it's harder to, out of the box, to have side channel leaks, things like that. They're actually they're more resistant to misusing a deterministic or an insecure random number generator. That's a classic problem we've seen over the decades of good algorithms weakened by implementation, just using a bad PRNG. So, and my point here is more of just, they've taken lessons from the past, and they've just said, let's have better designs. Forget about, in a way, the quantum computers themselves, and let's talk about the developers and developers' mental burden and the decisions that the developers have to make, and minimize all their mistakes so that these stay relatively secure. And the reason I'm going on about this is that, once again, this is my wish. Where are the good Appsec examples of this that aren't just prepared statements, which are kind of old, or like React, which is a little too cliche that I always go to with cross-site scripting frameworks or resistant frameworks? I would love more examples of these types of articles, and that's really what I would love to cover, so that we can be friends with Jen Easterly and CISA when they talk about secure design, and we can get federal funding for Application Security Weekly to be officially sponsored by the U.S. government. I don't know where I'm going with that, but who knows?
One thing that actually jumped out to me, Mike, is a little different than what you just covered, which is people have it that we have all these encryption algorithms right now that are good, and they're gonna, sort of save us. as it were. And then they have under implementation dangers, I'm not going to make the exact quote, but they functionally say, like, forget RSA. RSA is full of landmines, right? And another main point of this article then is that what we have already doesn't work as well as we think it does. So my takeaway from it is, why are we so worried about these quantum cracks, as it were, when what we have already doesn't really work as well as we'd like? We should focus on that and worry about quantum computing when it shows up, which the article also makes a point of. Quantum computing has been 20 years away for decades, right? We just don't know when it's coming. So let's focus on what's right in front of us.
Yes, a measured response, Kira, that doesn't use nits. This is amazing. I love it. This is the proper threat model. I strongly agree. But sorry, John, I stepped on you there.
Yeah, no. You're providing a affirmation, whereas I'm going in the opposite direction. The problem, Kira, is the media, and most of us don't. We follow the salacious thing, right? Ooh, quantum computing, sci-fi. Yeah, you're right. I think to me, the most tangible problem with quantum being quantum safe, your algorithms, encryption algorithms, is if I've got gigabytes or terabytes of data stored around somewhere that someone can get access to, that the encryption is perfectly fine on now, and they can hold that data to a point where their ability to crack it improves. That's sort of the problem that I think people who know what they're talking about and care are going after. It's not so much if I go out to gap.com is my SSL certificate quantum secure. It's that you've got a collection of data or you're transmitting data and you're trying to make sure that even if someone else takes it and holds onto it for 10 years, that you're not going to be in a bad position.
Yeah, and that's a great example of pointing out there's an Appsec cliche of, I'm full of cliches today, apologies, but your threat model is not my threat model. And John, you're pointing out that there are different actors out there who have different appreciations of threat models. And I think I would sort of say for our audience, Akira was pointing out on the day-to-day work, if we're dealing with a bunch of CVEs, et cetera, and we're trying to generate revenue for our new startup, quantum security is, quantum computers are not our concern. We're trying to build the site. Let's use Cloudflare for an example. Again, not being sponsored or anything, but like to get TSL 3 for free, or as an easy rollout for our system, rather than worry about what are the nuances of what the was it RSA, was it elliptic curves, was it a lattice framework, et cetera, where John is pointing out clearly that store and decrypt later, which easily be on the order of 10 years, 20 years, because storage is cheap. So John, since you've been providing some fun insights, and in this Trail of Bits article, I alluded to side channels and constant time. Power analysis is another type of side channel that you found a really fun article about. Tell us about this.
Yeah, this is a fun one. And RSA, actually, since Akira mentioned that. So, we covered a few articles in this space last year or year before when I was hardware nerding out. And I'm still a hardware nerd, maybe not as much on the show, but this one caught my attention in the last week or so. An individual has a project over on GitHub where they walk through how to do power analysis attack against a RSA encrypted data on a Arduino. So what really sort of, I think, catches my interest about this is, as I think about it, I'm pretty sure I've got an Arduino around the house. I've got the scope, I've got the breadboard, I've got all the other bits, and I can compile code and push it down to there. So without having to go to spend at least hundreds, if not thousands of dollars for some of the setups which you'd need for doing these type of things, like a chip whisperer, if you go down that path, you're able to actually experiment and work with this stuff at home quite easily. So I think that's really cool. I can't call it a blog, it sort of it is, but like this GitHub project itself, they walk through carefully in fairly basic terms, sort of what RSA is, the problems with RSA, here's the equipment we're going to be using, here's how we're going to set up and actually create the circuit so you can connect a probe to it and then visualize what's going on, run the code on there, actually see see the patterns on your scope and understand what that means. So I think it's really neatly done the way it's combining hands-on plus visual plus getting an understanding of this within, not too much difficulty or too much cost. So I think that I'm always looking for a chance to get this out in people's hands, and here's an example of that.
And it's really fun to see, too, just the physical manifestation of an encryption algorithm. Because as they point out, typically it's like with RSA, there's multiplication or addition. And those operations can take more time. And here is, if you scroll down to the results section, they're explaining how this side channel works is that voltage drops means there's a bit value of 1 of the key is being processed. Otherwise, that's a bit 0. And that's bit by bit. That's how you rebuild that key just by watching how long it takes, or in this case, not time, sorry, how much power, how much voltage is being used to do exponentiation for this very, very specific granular step of that process. And that to me, just again, I got nerd sniped by John from this article. I hadn't seen it before, but absolutely love it.
I love that you said nerd sniped because I feel like I also got nerd sniped. Thank you, John. In this article, they also have a section on the number theory of RSA. It's fabulous. It's not super long. It's not hard to understand. Definitely check that out if you want to know more about how RSA actually works.
So once again, this is the type of articles we like to see. Great educational and fun. So please, listeners, do send us more like this, especially if you're working on your own project. And here, John, I'm going to bring again another pair of articles. So we talked, I think, last week about the regression vuln from Qualys. Really, really fun, really neat research from them. There's another OpenSSH vuln found, and I'm going to tie this into the AI cyber challenge and Linux kernel vulns. But that's a little bit teaser of what's to come. But let's have you, John, talk to us a little bit about why yet another OpenSSH stands out to you.
Excuse me, you caught me a neon.
Another OpenSSH vuln.
Oh God, here we go.
I hear you.
And that is sort of part of the key part of this. This is a separate vuln to what we had come out week and a half ago. And I think because that a lot of people they're not fully realizing. I think they came out a little bit too close. But why they did, after Qualys released Regression, the branded vuln, which was basically at the heart of it a race vulnerability. One of the older names in application security, as well as I think the moderator of OSS security mailing list nowadays, Solar Designer, got a bit of a sense of like, hey, that gave me something to think about. Let me go and poke around, see if I can find something else related to that. And he did. So this is a very similar race condition to what was in Regression. What's interesting about this one is this is actually on, so modern SSH for the last 10, 15 years is privilege separated. Probably one of the earlier privilege separated applications that I think about it. But this vuln is on the low side of the priv sep. So it's not running as root. So if you get this compromise, you're able to execute against this, you're not going to get bang straight root in the box, but you're still getting that finger hold in there, right? Which then lets you to go and see what's on the box, what unpatched software is installed, or do you need to have root at all to get what you're trying to get? So I thought it was interesting, both from the concept of that spark being triggered and just had to go and actually let's dive a little bit deeper and see what else we can find. And then sort of resulting in vuln. One of the worries about this out there is since they came out close to each other is people might have just got done patching OpenSSH for those vulnerabilities which are vulnerable. And like they're like, hey, we're done, we're good. And
sorry.
Yeah, you don't realize that there's something else to do.
Yeah.
Okay.
Go
Go ahead, Mike.
Well, what I was going to say is part of this speaks to what like the idea of vulnerability density. Like, as you were saying, like the finger hold was the great phrase you used. And a little bit of that is the callback to the conversation we had with Stu when I mentioned, like, here's a bug bounty report, because this is an external workflow and API that's visible to some researcher. They found this one type of bug. That bug might be manifesting elsewhere. And the same thing with, here is OpenSSH code. It's been looked at for many, many years, but now back to back, two fun race conditions. So I'm going to set this up to say, well, what can AI do for this, or how could we apply this? And that's the OpenSSF article I have. But before we dive into that, Akira, I think you've got a question here.
Yeah, sure. So I have two things that I want to add. Earlier, offline, we were talking about when we're examining a vulnerability like this, especially if you're not as familiar with the in-depth nitty-gritty of the vulnerability, what's important to focus on? And what we decided is what's really important to focus on is what class of vulnerability is this falling into. And what I want to say to our listeners is that this is a potentially remote code execution class, so that it can give you that context to really understand, okay, what is the vulnerability actually doing here, as opposed to like, oh my gosh, like I don't understand what a race condition is or whatever all this math is, right? So just know it's a remote code execution vulnerability that maybe will give you some understanding of it as you maybe do your own research. The second thing I want to say is I know I'm probably beating a dead horse here, but this goes back to the quantum computing article where I personally make the argument of why we're worrying about quantum computing when we're having OpenSSH vulnerabilities. So that's all I'm going to say about it. But I just want to throw that in there, a little bit of a zing.
Yes, and you're right, because you're highlighting that aspect of impact. Like, what is the impact here? Is it, RCE, potentially that's going to be an impact. Maybe it'll be moderated a bit. As John mentioned, this is on the low priv side, so it's not going to be immediate root. But do we care about root in this day and age? Because maybe this process has access to secrets, or it's a service-to-service account. And anyway, I don't need to. I'm going off a tangent I didn't want to go on to, but because I was going to jokingly add, Solar Designer found this, so that's enough of a impact for me to appreciate and think we got to go fix it. But Solar Designer, there's a human with a well-deserved pedigree and level of trust within the community because of the work that he has done. We don't have the Solar Designer equivalent of AIs yet. Who knows if that's coming? And so what I pulled out here is a article called the AI Cyber Challenge and the Needle Linux Kernel Vuln. So an article from OpenSSF. And they're kind of giving just an overview of what to expect and how to prepare for the AI Cyber Challenge is coming up in DEF CON. And they're using this as an example. They're using a vulnerability from early, I think, January 2023, what they call the needle vuln, just basically a classic or a simple integer overflow within a single file, code file. And the reason they pointed this out is that it is, as described, relatively simple and straightforward in terms of integer overflow. We've got some signed and unsigned integers, getting together, cats and dogs, not getting along. Bad things happen, becomes a memory safety issue. And because it's relatively well-known class of vulnerability, the context of both where to find it as well as how to exploit it are all within the same physical file, that it should be the type of thing that's really easy for an AI to find. And so this also goes back to the Project Zero articles we covered a couple of weeks ago about how they were using RAGs in another name, agent-driven LLMs that Stu was talking about, with the idea that maybe LLMs or AI are really good at the easy vulns, but we have yet to see, how will they react here versus how will they react to a vuln that is a composition of a couple, it manifests across a couple different files, or the exploitability needs to set up a state where you need the context of a couple different files. That to me is what's going to be really interesting, why I'm looking forward to seeing what the semifinals are going to be like at DEF CON this year. So worry less about what the specific vulnerability is and more about what it represents. That was my thought going into this article.
Interesting. John, you want to take this one, or should I go for it?
I'm sort of at the opinion right now of, I'm very curious to watch how this goes at the conference. I think, at least for me, Mike said something that really sort of resonated back in the earlier static analysis days. If you had a vulnerability in a single file, you were fine, you could get it. But if you were starting to call functions in other files or something, that became version 2 or 3, Mike, that code was able
right.
to be intelligent enough that it would actually make the connection across files or libraries. So that gives you a sense of how early in the day this is. The analogy for me is I refer to 3D printing as we're in the dot matrix phase. So it's that same type of thing where there's a lot of space before we go get color laser printers. But yeah, that's just my thoughts on it, Akira. Where are you at?
Yeah, so I actually was interested in the cyber reasoning system. So it's these competing systems that identify vulnerabilities. They provide proof that the vulnerabilities are real, and then they develop fixes that don't mess with the software's functionality while they're doing it. So there's two interesting points here. Number one is that the fixes cannot screw up the software's functionality, right? So there's a book called Think Like a Programmer, where it's by V. Anton Sproul. It's one of my favorite books. And in that book, he talks about how problems can sometimes become easier to solve within stricter and stricter constraints, right? So the problems itself, I think, are going to be actually solved properly by including this very small sort of side note of like, oh, by the way, you can't break this stuff. The second thing that I thought was interesting actually ties back to our conversation with Sean just now, is that it needs to provide evidence that the vulnerabilities are real. So this goes back to Sean's point of validation. So is this actually true? Once we test it, are we finding that the vulnerabilities are legitimate? And that'll be interesting to see how LLM becomes sort of self-referential in this instance.
Yeah, Stu, not Sean. But quick comment.
Me, I'm sorry.
And yeah, I think that's part of the point of that we're going to see is how well do. I'm going to use the phrasing. We don't care about the LLMs finding or AI finding the vulns. We care more about, can it exploit it? Meaning, does it give us that context of impact, or should this be part of our threat model? To go back to kind of what you were saying, Akira, as well as can you fix it in a way that has no side effects to the intended operation of the product? And because that is where you're saving time of developers, and that's where, if it gets demonstrated that works, I will be quite happy. I think right now, not to give away too much, but I may be a little bit skeptical, or just want to see where we go with that.
That's super difficult to do, even for humans.
Even for humans, yeah.
To fix a vulnerability and know that it's accurate and not incur either another vulnerability or another bug, that's really tough. So, I mean, an automated system is, if the automated system is done well and has a wide enough test coverage, that's sort of ideal, because it can, I mean, you could probably just iterate through a bunch of different fixes till you get the right one, right? Do sort of the crazy monkey type thing. But yeah, that's the tough part. We'll see.
We'll see. And part of it, just as maybe one more comment for me too, is in the idea of that integer underflow or overflow for that matter, compilers already know the types and they can already warn about potential mismatches. So in a way too is, do we need the AI and LLMs for this? Or do we just need to pay attention to the compilers that are complaining about these particular mathematical operations? Or can the compilers just expand them into, here's going to be we'll do this in 16-bit arithmetic, and then say, we know it's not negative, we're going to bring it back down into that 8-bit, which is a bit hand-wavy, but that's kind of why, like, why do we even need an AI here? But we'll save that question as an exercise for the listeners over the next week. I did want to real quick end with one final article. Again, we're having fun this week. New articles of incorporation and bylaws for the OWASP Foundation. So this stood out because Andrew Vanderstock was digging into some of the history of OWASP and realizing, for a couple of years, they weren't actually incorporated as a foundation in all the best ways as they should have been. And here, more of the metaphor I want to take from this is, one, I guess it's time to develop a top 10 list for running a foundation. That could be helpful. But two, there's a metaphor here, the sense of Appsec is more than just code. There are compliance aspect, there are political aspects in the sense of working with other people. And we can't just always say, here's that integer underflow, go fix this, or here's the cross-site scripting, you should have done this. It's more that conversation of threat models. Do I care about this? What do I do? Does this fix? How does this fix impact the product's functionality or not? And so maybe it's a bit of a stretch, but I did want to have a little bit of fun with this particular article as we wrap up the show.
So I remember about 6 months ago, there was a bunch of articles that came out saying that OWASP needs to evolve. And I'm curious how many of those points were taken in as they were creating these new bylaws. And I haven't read the bylaws in full disclosure, but I wonder how many people it'll sort of bring back into the fold.
I think that those are definitely separate concerns, and this is more about just making sure that members are members, and that the foundation can take in donations, for example, and curate and spend those donations in a way that adheres to the U.S. laws. So the future of OWASP is perhaps, as listeners may have picked up about the top 10 list running foundation. That was my nod to that other aspect of the evolution there, Kara. John, is there anything that you want to wrap up this news segment for us for this week?
I don't think I have another top 10 story for our top 10 stories, so I think I'm going to leave it at that.
There we go. So we've got top 3 hosts of ASW talking about top 10s and all the news. So I want to say thank you to John. Thank you to Akira. Thank you for everyone who's been joining us. Please remember to subscribe, share us on the socials, check out the show notes. And speaking of developers, check out Heroes by the Midnight. We'll see you next week on Application Security Weekly.